Lesson 9.2, Task 6. Solve real-world problems using substitution. On opening night for a new play, a theater sold 639 tickets for the main floor and the balcony. Total, they sold $5,824 more of main floor tickets than balcony tickets. How many of each type of ticket were sold? All right, so it shows here that the balcony tickets are $17 and the main floor tickets are $24. All right, so it says write a system of equations to model the situation using the given information. All right, so using the information above, so it's going to say use a verbal model to write each equation. Let X represent the number of main floor tickets and Y represent the number of balcony tickets. So main floor tickets plus balcony tickets equals 639 total tickets. So that's one equation. Our second equation, the value of the main floor tickets, they're $24 each, so 24 times X, minus the difference in sales, $5,824, equals the balcony tickets, 17Y. And that just comes from reading this up here. Okay, so they just took this information and put it into an equation. All right, so it says, so the system of equations is X plus Y equals 639 and 24X minus 5,824 equals 17Y. Use the substitution method to solve. All right, so if we use the substitution method to solve, it says, does it matter which variable you use? No, it does not. Especially for the first equation, they both have X and Y, so you could get either variable by itself very quickly. All right, next substitute this expression into the other equation. So they substitute that in, and they solve for Y. And it says Y equals 232. So you can see up here again, Y was the number of balcony tickets. All right, so according to the variable definition, 232 is the number of balcony tickets sold. All right, use the value of Y to solve for X. So they're going to take that 232, put it back into the equation. So we had X plus Y equals 639. So just substitute that 232 in and then subtract from both sides, and that gives you X. According to the variable definition, 407 is the number of main floor tickets sold. Remember, X was main floor tickets sold. All right, so it says the solution of the system is 407 and 232. What does that mean? That means the theater sold 407 main floor tickets, that was our X, and 232 balcony tickets, which was our Y. So that's our X and Y ordered pair there. All right, that's all for task 6. If you have any questions, let me know. All right, guys, I'm going to go through a couple examples for substitution. So remember the steps. Solve one of the equations for one of its variables. Substitute the expression from step 1 into the other equation and solve for the other variable. Substitute the value from step 2 into either original equation and solve to find the value of the other variable. All right. All right, so here's an example. Y equals negative 3x plus 14 and x equals 3y minus 12. Now, anytime you see this bracket here, that it indicates that these two equations are together. So this tells us that we are working with a system of equations. Remember, system of equations is two or more equations. So we're trying to find the solution here. All right, so the first equation, y equals this, or x equals this for the second equation. So we can start with either equation. So let's say that x equals this. So let's take this and substitute it here for x. So let's see what happens. So we're going to have y equals negative 3 times, instead of x, now we're going to replace x with 3y minus 12, and then we're going to add 14. All right, so then we're going to have to do distributive property. So we're going to get negative 9y. A negative and a negative makes this a positive. So we get positive 36 and then plus 14. Now we're going to combine like terms. So let's go ahead and add 9 to the other side. So we've got this one cancels. 1 plus 9 is 10y. And 36 plus 14, that would be 40, 50. Divide by 10 on both sides. And we solve for y. Alright, so we have y. Now we need to find x. Well, in the second equation, it says x equals this right here. So let's use the second equation to see what x is. So 3 times y minus 12. We just found out that y is 5, so we can put that here. So x equals 3 times 5 is 15 minus 12, or 3. Alright, even though we found y first, we know that our ordered pairs is always x, y. So we're going to put x, then y, and that would be the solution to our system. So that shows us that this system is a independent system. It has one solution. Alright, next example. Alright, this one is in standard form, x plus y equals 4 and negative x minus y equals 6. So we're going to have to solve for one of the variables first. Alright, so very quickly we can subtract one of the x or the y, it doesn't matter. So let's go ahead and say x equals negative y plus 4. So all I did was subtract y and put it on the other side. That way we know x equals this, and I can now substitute that here. Alright, so we have negative whatever x is. So x is now negative y plus 4. See how I put that parentheses too? Because we're going to have to distribute that negative sign to all of x. And then minus y equals 6. Alright, so now distribute the negative. So that's going to be plus y minus 4 minus y equals 6. Plus and minus y cancel. Negative 4 equals 6. Uh-oh, so that's not true. That is not a true statement, which means there is no solution to this system. So if you graph this, you would find that there's no intersection points. So this system is inconsistent. All right, let's look at the next example. All right, the next example, x would be the easiest to solve for. So let's go ahead and say x equals, if we add 3y to the other side, we get 3y plus 6. Then we can take the 3y plus 6 and substitute that in place of x right here. So we're going to have 4 times x minus 12y equals 24. And in place of x, we are going to substitute 3y plus 6. And again, you can solve for any variable, but when I look at these two equations, x is definitely the easiest to solve for. All right, so I'm going to distribute again. So I'm going to have 3 times 4, so 12y. 4 times 6. Bring down all this other stuff. And then combine like terms. So I'm going to have 12 and minus 12 are on the same side. Now I have 24 equals 24. Okay, so this is a true statement. So that means these are equivalent expressions, which means that this is all real numbers. So infinite number of solutions. All right, so can we make this equation look like this equation? What if we divide this equation by 4? So if we take 4x minus 12y equals 24, if we divide everything by 4, we get x minus 3y equals 6. So this equation is the same as this equation. So you can see that those are equivalent. That means all solutions work. They have every point in common. So that's infinite number of solutions. Those would be called a dependent system. All right, let's look at one more example. All right, both of these have x by themselves, so you can start with either equation. I'm going to start with the first one and just write this as x equals. I'm going to add 3y to the other side and make sure I have my 10. All right, so this can be substituted in place of x here. So I'm going to have 3y plus 10 plus 5y equals negative 22. All right, so my 3 and my 5 are on the same side of the equation, so I can combine like terms. And then I'm going to subtract 10. So I'm going to have 8y equals negative 32. Divide both sides by 8. Y equals negative 8 goes into 32 4 times. So y is negative 4. Now I have to find x. So I can use either one of my original equations. I know that this is equivalent to my original equation, and I'm looking for x. So I'm going to use this equation right here. X equals 3 times y plus 10. And we know that y now is negative 4. So x equals negative 12 plus 10, or negative 2. And again, it's always written as x, then y. So the solution to this system is negative 2, negative 4. How do you check that? You can graph it and see if that's the intersection point, or you can plug negative 2 in for x and negative 4 in for y and see if both equations work. So let's try that. Negative 2, let me write it down real quick. All right, so x is negative 2 minus 3 times negative 4. Does that equal 10? So I've got negative 2 and a negative 3 times negative 4 is plus 12. Negative 2 plus 12 is 10. 10 equals 10, so it works for the first equation. Let's see if it works for the second equation as well. So x is negative 2 plus 5y. Does that equal negative 22? So we got negative 2 minus 20, negative 22 equals negative 22. So you can see that does work. So this is the solution for the system. So you can either graph it and check your answers, or you can substitute the x and y in both equations and check your solution. All right, that's all for 9.2. If you have any questions, let me know.